In this video, we'll talk about the Pythagorean Theorem and how to utilize it for solving for sides on a right triangle. So first off, let's talk about what the Pythagorean Theorem is and see what we can apply it to. So the Pythagorean Theorem applies to right triangles and right triangles only. And recall that right triangles have a 90-degree angle in them. So for the sake of the sake, let's just call this side here the hypotenuse, C. And the hypotenuse is just a fancy term for the big side of a right triangle. It's always across from the 90-degree angle. It'll always be the biggest side, and that'll come into play here in about a minute. And let's call the other two sides A and B. And both of these, just for terminology's sake, are called the legs of a right triangle. So Pythagorean theorem states that if you have a right triangle set up like this, then a squared plus b squared is equal to c squared. Now there are all kinds of proofs online that you can go find. If you don't believe it, check them out. If you're cool with just accepting this as a formula you can use, I'm fine with that. Let's just take that for now and run through a couple examples. So we can use Pythagorean theorem to solve for a third side of a right triangle if we already have two. So in this example, 3 would be your A, 4 would be your B, and X is kind of your C, so to speak. It's the hypotenuse. So if I was to set this up, it would be 3 squared plus 4 squared is equal to X squared. A squared plus B squared equals C squared. Let's simplify a little bit. So 9 plus 16 would then equal X squared, which means that X squared is equal to 25, which we square root both sides. X has to be 5. So this is a classic Pythagorean triple, 3, 4, 5, since they're all whole numbers. It's kind of the simplest case. This kind of triangle is used all the time, just as an FYI. This is how we can use Pythagorean theorem to solve for the hypotenuse on a triangle. Now if we look at another example, in this case, solving for x, we don't know we do know the hypotenuse, but we don't know one of the legs. This is the one I don't know. So let's say this is our B, so to speak. This would still be our A, and the hypotenuse would still be our C. So let's plug it in. A squared would be 3 squared plus X squared, because that's our B, equals 7 squared, our C squared. Okay, again we will simplify. So we have 9 plus x squared equals 49. Then we'll subtract 9 from both sides. So x squared has to equal 40. And then x will equal the square root of 40. And I think we can all agree this will be an irrational number, since it's not a perfect square. I think we can all agree that it would be somewhere between 6 and 7. So x would be roughly 6 point something, which we could run to the calculator and figure it out. However, this would be an exact solution right here. And if we needed to give an approximation, then we run to the calculator. Okay, that's Pythagorean theorem. We can use it to solve for another side if we know two others on right triangles and right triangles only. I hope this video helps.